Good evening. I'm very pleased and honored to host this event. I thank the iGreat for the opportunity. My name is Lucio Lamberti. I am a professor of marketing at Politecnico di Milano, the leading technical university in Italy. And I chair a lab that is a lab of applied bioscience for the study of human behavior that is called PHIL, Physiology, Emotion and Experience Lab. I am particularly pleased and honored to be the host of this panel session about HMI in the automotive. And I would like to introduce you and to thank for attending and participating this meeting our very reputed guests that are Davide Gaglione. Hello, Davide.
Hi.
HMI responsible at Lamborghini.
Hi, nice to meet you. Yes, Davide Gaglione speaking. I'm the HMI responsible at Lamborghini side, and I work principally in the department of R&D, research and development. My principal activities are related to the realization of the HMI concept and obviously of the development with the related steering of the supplier for the implementation of the software in the target involved. So principally my area of interest are related to the HMI simulation and also regarding some heuristic about the possibility to make more objective the human-machine interface due to the possibility of a lot of different idea of different people. So for me, it's interesting how it's possible to evaluate an objective methods that allow to assign some value to the quality and in general also the functionality related to the human-machine interface from also an ergonomic point of view and so on. I'm working principally on the in transversal way on all the project currently in a Lamborghini like Huracan, Aventador and Urus. And at the moment, one or two of my goals are related also to the process definition about the scheduling of the activity of the HMI, because usually we follow a process for the realization of the concept and also related to the timing of the development. But in a lot of cases, I think that this is a problem, a general problem for all the OEM when it's too late or when the software and the HMI is ready in the Proto, for example, or also in the Zero series of the car. Sometime the board, the technical director and so on requires some modification that have an impact on the development and also on the start of a production and so on. I don't know if it's a common problem also for the other OEM, but my purpose is also to make more order and to make better the process of the request, and also in order to define some deadline. And my purpose is also to respect this kind of deadline in order to create to not create confusion.
Okay, thank you very much, Davide, for this introduction. We will come back to you to discuss some HMI specific issues after the presentation of the other guest. We pass from Lamborghini to Maserati, Stellantis Group, with Fabrizio Picariello. Fabrizio, welcome and thank you for being here.
Thank you, and thank you for inviting me to this interesting event. And it is very good to be there. I'm very pleased. I'm Fabrizio Picariello. I'm working in Maserati, and I'm the simulator global lead for Stellantis. in this group, of course, I take this position on HMI ergonomics and perceived quality and craftsmanship team. My role in the company is to provide this, let's say, service to the team, creating the HMI prototyping and integrating them into the driving simulator. This is made using several labs into the globe. So we have facilities in Modena, Torino, and Auburn Hills, and of course we have a good team in Chennai too. And this is the main goal of our team is to create a good integration among these different labs to do, generally speaking, the same that Davide said. So anticipate as far as possible the needs, the requests coming from top manager, but not only coming from the customer. This is our main reason. So starting from user-centered design, working hard with the HMI team, define what is needed to implement in a very, very fast way, and passing through virtual reality to driving simulators as soon as possible.
Thank you very much, Fabrizio. Basically, we have the luck of meeting, by the way, two OEM that used to be particularly focused on sport car in their DNA, let's say. And both of them, with the Urus and the Levante projects, have gone through and towards a broader market in which the driving experience in terms also of HMI is getting more and more significant. We will go through this kind of point later on in our debate. Together with the OEM, we also have a guest that talks about innovative mobility solutions. Panos Konstantopoulos from Arrival London. Welcome, Panos.
Thank you very much, Lucio. Thank you very much. My name is Panos. I'm working at Arrival, like you said, mobility solution with electric commercial vehicles. We recently announced the car as well. So our key products are the van, the bus, the car, and obviously, like you said, we provide the mobility solutions working with cities to change the transportation. So I am leading the human-machine interface and user experience platform. What that means is that we are trying to understand how users interact with in-vehicle technology, both physical and digital, and try to make those interactions safer, easier, increasing usability, and try to add a little bit of Arrival magic. I know that my colleagues from other OEMs talked about obviously different products. In our case, most of our products are commercial products. So we're not only designing a driving position, we're designing a workspace. So we put a lot of emphasis on physical ergonomics, wellness, and comfort. It is within our remit, so we do physical and digital interfaces. Some key areas, you know, I have spent a lot of years for studying driver distraction and driver workload in our attempt to make as safer and easy to use interfaces. In vehicle technology, I work within technology group, so we are trying some advanced HMI concepts, and of course, user experience, which includes human factors, ergonomics, and interactions. Some of my team supports all products at Arrival. On the public domain, like I said, we have a bus, a van, and a car. In addition, we are developing some prototypes, some concepts. We have a fairly good driving simulator, and we have plans to expand that, to make it more, to add more capabilities. And like some of my colleagues mentioned already, we're trying to explore virtual reality and mixed reality to see how we can add value and add robustness to our testing. And yeah, I think that's a good introduction. We will discuss more details later.
A very good introduction, Panos. Thank you very much for providing us with. Virtual vehicle, Paolo Pretto. Thank you very much, Paolo, for being here with us. And the floor is yours. Paolo, can you hear us? Your mic is
now
muted.
you can hear me, right?
Now we can.
Okay, perfect. Sorry, little technical glitches. Okay, so yeah, thank you for also inviting me to taking part to this roundtable. I work in a medium company called Virtual Vehicle, located in Graz in Austria, and focus on research projects, applied research in the transportation and mobility domains, and in particular in automotive and rail. So I have a work at very much at the international level. We have we were partially funded by public money and by also private money. So we work with companies, we work with industry, with academics. So we're really a bridge in between different worlds and different needs. My role in the company is especially in the field of human factors of transportation. I'm responsible for this area of research, and also for the human in the loop driving simulation aspect. So we have created a lab, which we call Drive Lab, that consists of different simulators that are connected with each other, and where we can study the interactions between not only the driver and the vehicle, but also between driver, vehicles, and environment, where the environment include other road users, but also really environmental conditions and infrastructure information. We have a system that is a hybrid system. That means that we can plug in also real automated vehicles and that they can exchange information within the simulation environment. So we have a driver sitting in the simulator, a driver sitting in the real car, and interacting with each other. It's a very challenging and interesting setup with a lot of potential for the research we're doing. We are coordinating several European projects at the moment, one of which is developing a very interesting concept of HMI, which we call fluid HMI. We'll probably have the time to go more in detail on that later on. But so our goal, let's say our vision, is really to create an HMI that can support the driver and the occupants driving and non-driving related activities in the vehicles of the future, but also in the vehicles of today, let's say, I mean, with partial automation functions. Our global view is really to achieve a way to teach automated vehicles to drive in a human-like way, which does not mean like in a reckless way like humans do, but to really mean to bridge and bring together the best of both worlds, the best of state-of-the-art technology and safety with the best of what humans can do, which means interpret and interpret an environment and understand the way to move through it in the most efficient way. So that's what we call the human-like automated driving. We're also working on integrating HMI into larger safety concepts that do not involve only features within the own vehicle, like safety system, restraint safety system, and so on, but really a more altruistic concept of safety, where multiple vehicles cooperate with each other in increasing the overall traffic safety, and that thanks to the sharing of information of which the driver state, psychophysical state is part of. Thank you.
Thank you very much, Paolo. We will go back to this idea of fluid HMI in our discussion and all the other things we have put on the table, because it's a very interesting point of view. We also have managers of companies that provide services for testing for HMI and other applications. So I'm particularly pleased to introduce you Ulf Lofberg from Smartai. And Ulf, the floor is yours.
Thank you, Lucio. Yes, I'm also very happy to be part of this workshop. I represent Smartai from Sweden, Gothenburg. We are producers of research instruments for the automotive industry and other industries, and we especially focus on head and eye tracking solutions. These come in very handy when it comes to HMI designs. We have two other business units which basically deal with the DMS or driver monitoring systems. I will not be talking too much about that today. So we're focusing on R&D today and of course HMI. Main interest for us is the HMI, but also human factors and driver behavior in automotive. Our solutions come in handy when it comes to projects that touch road safety, drowsiness, ADAS, and of course HMI design as well.
Okay.
At the end of the day, we have a ultimate goal of helping to reduce traffic accident and to help researchers to better understand the driver behavior and shape the future of cockpit layout. So our tools are used since 20 years now, and VI Grade is one of our customers as well, but also many of the OEMs and other smaller and bigger companies. My role is sales director, and I cover the European market. Thank you.
Thank you very much, Ulf. You are putting on the table an aspect that is related to HMI, that is how HMI can improve also safety on the vehicle, not only the full accomplishment of all the performances of the vehicle. And this is something we're going to discuss later on during our roundtable. Last but surely not least, we have iMotions, and in particular Nam and Nguyen, Senior Neuroscience Product Specialist at iMotions. I welcome you on board, Nam, and the stage is yours.
Absolutely. Thank you so much. Very happy to be here. So yeah, iMotions is a backbone software with over 1,300 clients where we're able to support multiple devices onto your simulation. So we're able to take device information from fantastic partners such as the Smarteye Pro and other types to combine with things like EEG, GSR, facial expressions. And these can be bolted onto your various types of R&D efforts, whether it's desktop-based inside a simulator or a car on the track. Essentially, our clients use our tool set in order to further their research into using different types of these sensors to diagnose how people are responding in the moment. So with eye tracking, you can tell attention, where they're paying, attention to the details of inside the car, outside the car. EEG might give you things like cognitive workload, heart rate, and skin response might give you emotional responses. Facial expressions would give you different types of emotional content as well. And with these tools, they're able to then get deeper insights into their HMI design, safety, and a variety of other research missions that they're looking to try to do. Thank you very much.
Thank you, Nam. I stopped sharing my screen and because I want to look a little bit better in your faces, and I will start with our roundtable, and I would start from the OEM, from the car makers, asking them what is the role of HMI in designing a car today. We know that the technology in the car is evolving very fast. The functionalities and the features are becoming more and more complex, more and more powerful too. And so UX is getting, and human machine interface is getting more and more, let's say, important in the development and the design of the products. So, as I said before, both Maserati and Lamborghini went through dramatic innovation and radical innovation in their products. So I would like to ask first Davide and then Fabrizio, what is the role of HMI in the design cycle of an automotive, of a car maker in this moment? Davide.
Okay, so principally in the last year, the rule of the HMI inside the vehicle has been take a lot of importance. I mean, because 5 or 6 years ago, maybe the HMI was only the instrument cluster, for example, the steering wheel and some switches. So with the new technology and the new functionality present inside the car, like also, for example, for the ADAS and also the other ECU, the number and the kind of the information to show to the user on 1, 2, 3 display are the number is so high. So principally at the moment, this is also in the last year a revolution about this topic that first of all also for the super sport car previously was not so important, because for a super sport car the most important thing were, for example, the engine, the chassis, and all the functionality related to the vehicle dynamic principally. Now the challenge is to make more comprehensible all of this information to the user in a way so easy, but also in order to make some that it's done by an engineer to a normal people, to a normal person. So I can give you my example. I am Lamborghini since 2018, so 2 years ago, and I am the only one at the moment that work principally on the HMI and user experience, because this is principally a new rule, and I have I interface myself with the component owner, but first of all, before there were only the component owner of the cluster, and there was the HMI. So at the moment, this is the challenge, to make more easier the information, to understand what are the best solution for the size of display. For example, for the resolution, the central display should be small, should be big, and there are a lot of subjective point of view that we need to take care. This is the reason why I'm interested also about the possibility to evaluate with an objective point of view the HMI.
Thank you very much, Davide. You put
too.
on the table this idea of HMI as an enhancer of the driving experience. Let's see if also in Maserati this is the philosophy, that is HMI aims at providing something more, so more information, or if you have another idea about the concept of enhancement of the experience.
The basics are similar, I should say. In Maserati, but I can extend easily to Stellantis. So any other part of the company. In the last years, we put a lot of interest, a lot of attention in developing the HMI, since we strongly believe that is a very, very key fact to the user experience, and so it is a reason to buy more and more. As the colleague said, vehicle dynamics, chassis, driving experience itself is already acquired. It is something that people expect. So you have to work on that topics, and you have to have the right instruments, the right tools to give more and more in detail and structure this part. But anyway, people now are focusing on their experience. So the paradigm is shifting, because people are dealing with smartphones, are dealing with more powerful PC and digital experiences. So also socials are part of our daily life. So the total experience that people have with the with the digital life is completely different, and they want to take this experience into the car. They want to have a seamless experience moving from their home to their car to their work. So this is our new mission, to work on something that can allow this experience and make it pleasant, and of course having the possibility to be less destructive at all, because we have a huge impact on the safety on road. We touched this topic in our discussion before, and it is very dramatic, the amount of information that we are providing to people into the cars. I followed what Davide said. We started with very few information, very dedicated. This is special in sport car, but it is true for medium to low segments too. And we are providing more and more information. You can think easily what was the radio in your car 10 years ago, and what is the digital experience today. And there is another key fact that I want to discuss with you. I want to pass to this discussion, and it is the difference in the type of HMI we are dealing with. So we pass from a functional HMI that, just to be clear, it is just the LED with the icon that inform you that the system is working properly or not, to an informative. So there is not the LED only and the icon, but there is a message and possibly the context. And now we are moving to interactive HMI and proactive HMI. So it is an evolution that we are following and we are leading. And this is why we need to work on the specification, of course, but in the internal integration with style, electronic department, and of course our HMI role is a key role together with product.
Thank you very much, Fabrizio, because if we combine what you said with what Davide said, basically we are talking about HMI as a new competitive advantage in the automotive industry. So
it is
one of the reason why customers choose a specific kind of vehicle. I'm pretty sure that Ulf would add something related also to what HMI should not do, that is distracting and increasing the risks. But we will arrive to this in a moment. Before, I would like from Panos and Paolo instead talk about the user experience and talk about the role of HMI in a fluid HMI, for instance, as Paolo talked about in his project. I would like, so Paolo, to tell us something about this fluid HMI project and this fluid HMI idea. And then with Panos, we will talk about its application to the mobility solutions.
Yeah, thank you, Lucio. That's actually indeed a very appropriate point, is because I feel like it can very much complement and integrate what Fabrizio and Davide were saying before. And so the interface is no longer an icon or an information telling me something about the system. It's definitely a bidirectional communication and interaction system that is really surrounding and supporting the environment in many different ways, and not only the driver, basically. Right? So we're talking here about driving related and non-driving related activities that are possible in increasing automated vehicles, right? So that means that the HMI becomes responsible here for supporting all of these special activities that were, until a few years ago, not even conceivable in a vehicle, right? I mean, at least in legal terms. And so now they are possible. Soon they will be definitely possible, and even more and more. Right? So that's our horizon. It's expanding towards automation. So HMI is basically ultimately also responsible for shaping and adapting not only the interiors of the vehicle in terms of interaction and communication, but also the interaction and communication to the exteriors. So the vehicle is an interface both ways. So the concept of interface is really expanding, and its complexity is expanding accordingly. Complexity, which on one side is definitely a challenging task for us, for researchers, for engineers and so on, for practitioners, but also it's an extremely attracting and exciting field, right? We have possibilities that were impossible until a few years ago. Point is that such a complex system needs really many components, need a huge architecture, need a huge I'd say a framework to work, and essentially needs a driver monitoring system, something that interfaces of few generations ago couldn't bother with. But so now a driver monitoring system that includes biosignals, that includes the interpretation of drivers' biosignals into an estimate of the driver's state. Is the driver being distracted, being attentive, being fatigued, or being is he looking away because is he staring to the front because he's paying a lot of attention to the road, or because he's lost in his own thoughts and therefore totally distracted but still fixing the road, right? So we need to understand these states. We need to make use of these states and integrate that information. When the information is coming from the vehicle, what is the state of the vehicle? So the HMI becomes more and more a sentient system, a system that needs to know about the driver, needs to know about the vehicle, needs to know about the infrastructure and the environment around. And this is a unified system. It's a giant pot in which interactions and communications flow continuously. So this concept of HMI, fluid HMI, is a metaphor. Because a fluid, what are the features of a fluid, right? The fluid can adapt to the container. The fluid also is shaped around a body that is immersed in that fluid. So if the body is the driver, and the body we're talking about is not the physical aspects, or not only, or for a small part, only it's a physical aspect, but for the major part, it's the cognitive envelope. So it's the psychological description of what the driver's state is in that specific moment, in that specific situation. So the fluid is the perfect mean that can take that shape and that can support the driver activity, whatever the activity is, and make sure that that activity is compatible with the driving mode, with the driving conditions. And if not, the HMI system is a system that knows what intervention needs to be triggered and how that intervention needs to be triggered. And that's here what you mentioned before, the role of HMI as a safety system, right? So HMI becomes also responsible of tutoring the driver, of teaching the driver, of exposing the driver to information and steering the driver state and the driver behavior in a way that make it more fit to the situation, more suitable to the situation, and that in general increase the overall safety of the system. Not only the safety, of course, HMI becomes also responsible for the comfort. It's not just me changing the air conditioning. That's not anymore the HMI we're interested in. We are looking a few steps ahead here, right, in terms of HMI. The HMI is the system that is making use of AI black box algorithm and so machine learning algorithms and model-based knowledge is capable of tuning the environment of the interiors to make the ride as comfortable as possible. Yeah. So
thank you very
this
much.
is in a nutshell, let's say, the summary of a multi-years, multi-millions, and multi-partners European project we are coordinating in that sense.
Thank you very much, Paolo, because you put on the table this idea of not only a driving enhancement in the enjoyment of your own vehicle, but also a kind of optimization of the experience with respect to the environment in a broad sense. So you're putting on the table an issue that is very interesting, and and I take the occasion for encouraging participants to make their questions in the Q&A session. I would try to moderate consistently with a strict timeline that we have, to ask Panos a thing that I had in mind from the beginning, but it's also a question raised. That is, what is the change in HMI when the object of this HMI is not your private car, but a public service vehicle, such as a bus?
Yeah. And I saw the question. I'll try to, I mean, Paolo made a very good framework of different concepts. I would like to provide 3 or 4 examples how I think we're all aligned here. Just 3 or 4 examples how we try to tackle those things. So then again, HMI can be a broad term. I would like to say that for us, HMI, good HMI and user experience starts with the driving position, because like I said, we have people that they are there for 8 hours. So we put a lot of emphasis on wellness and driver comfort, but also that concept of fluidity. And to tackle the question, in our case includes exterior HMI to communicate the location of the next station, some advertising components on the bus. Also, the question raised about the occupant and the passenger experience as well, how we're trying to harmonize the interface and the user experience between the passengers and the driver to have some sort of harmonization. So yes, there is a lot of research on the individual touch points within the bus and the van. We will see some examples later. We mentioned about safety. For us, this is the fundamental aspect of human-machine interface. Again, how we connect the physical, the steering wheel, the stocks with the digital, with the display. We have I think a very brave approach on our display technologies. Davide mentioned how we need to be mindful of the resolution. I fully agree. I would like to add, in our case, how specific we need to be about the brightness as well of those displays for people that are driving at night, driving for many hours. So we'll take very careful consideration.
Also about the colors, for example.
Exactly. The visual performance in general of displays is very critical for us. So safety. In terms of features, obviously this is a commercial setting. We're trying to, and this is an internal conversation, we're trying to have as less features, only the necessary features for usability and to perform the tasks, not a lot of features. In general, we're trying to add a lot of evidence if we need to add a feature, and the harmonization. And obviously, Ulf will mention more details, but we use objective measurements. Eyes of road, eye movements eye tracking is a tool that we utilize a lot to make sure that we have that safety component. Very briefly, I would like to mention something that to NAM. In our case, because we have a lot of passengers as well, we're trying to have inclusive design, try to design for everyone. So we take that into consideration. It is another level of complexity for us, but it is very important and we devote a lot of resources. Last example is some programs that we have on the public domain. Paolo mentioned about the future. We have more autonomous features coming, maybe not to the speed, to the expectation that we all had, but nevertheless, the autonomous features are coming. So we have a robo-race program and a robo-pilot program, just to understand how we can push the limit of artificial intelligence, taking the boring and difficult tasks from the driver and create that better user experience. So
thank you very much, Panos.
I gave some practical examples based on Paolo's theoretical framework, how we try to tackle those things, but I think we're fully aligned here.
I would like to thank you for the detailed overview that you are putting on the table. It's also because you put on the table an issue that is very important, that is the amount of information that can be shared with the user of a vehicle is increasing. HMI can make it much easier to transmit, interact, and communicate this kind of information, but there is always the risk of an overload of this kind of information. So Ulf, as an expert in safety, I would like to ask you if you have some remarks on this idea, that is the proper balance between the amount of information provided and the impact on driving performances in terms of distraction, safety, and so on.
Well, it's, going back to Paolo's summary there, I think it touched many different things. Safety is absolutely one topic which we are involved in on a broad basis. From a research perspective as well. And Paolo's description was good, I think, because it showed the many levels of the HMI. I mean, it's no longer a matter of just understanding where information should go to make it easy for the driver. I mean, the HMI has more or less the purpose of a entertainment or a theater today, even, It also has the purpose of making sure the driver is operating the car in a safe way on the road, in the traffic. But it also has the function, or could have the function, of supporting the driver in different areas, and that then goes into the topic that Panos touched as well, when it comes to the transition between a driver driving the car and the car actually taking over, so an autonomous activity by the car. From our perspective, we see all of this, in the eye tracking world. Safety is always the main concern. How do you design your HMI so that the driver is not distracted? You will always have a certain distraction, but it needs to be minimized. For all these different levels, the HMI has to be adaptive, so that when you do certain activity, you always optimize the safety. And our tools, or the research part, or the R&D tools that eye tracking provide, and the functionality it provides, gives you always options to, from the driver, see what's going on and help the driver. We see this in several projects where sort of a co-pilot is being designed, where the HMI is a part of that. So you can, depending on what you're currently doing, if you're driving or if you're standing still, the HMI shows you different things, all of these things. And at the end of the day, it's all about the safety, and safety you can split, when it comes to the eye tracking, it's about the safety, and you can split it in different segments. So the driver itself, the state of the driver, is there a driver in the seat at all? Is the driver alive? Is the driver awake? If he's awake, how tired is the driver? So these are the DMS systems that we see today already being implemented. But it's also the matter of distraction. How much does the driver see that is going on around him? And that's, of course, also a very important thing. So eyes on road is one aspect there. If you're dealing too much with your navigation or the other parts of the HMI, and you don't look at the road, all of these topics can also be covered by an eye tracking solution, or head and eye tracking solution. So that is what we see from the Smartai side.
Thank you very much, Ulf. I would like to complement your view with NAM view. NAM, in particular, I would like to ask you something about something that Panos anticipated. That is the fact that whenever we deal with HMI and information exchange, we also deal with the idea of effectiveness of communication. And effectiveness of communication changes dramatically according to the social demographics, for instance, of the user. Many OEM, many mobility solution provider work at a global level. So I would like to understand this idea of personalization, customization of the driving experience, and how can we work on understanding the effectiveness respect with diversity of HMI systems?
Absolutely. I think it all comes in terms of the way that you're researching your designs when you go about that. I'm going to specifically bring up an example of a client. They switched from touchscreens that were this big to touchscreens that were 400% larger, so much bigger. And now they have all this real estate to put switches anywhere in there. There's this button there. Should it be a rotary dial? Should it be? Should it have a label as a word, or should it have an icon? Should it have all these types of things? And when the people of different demographics are being brought in and ask, okay, can you change the temperature? Can you increase the volume? Can you change the seat things? Then you can leverage these tools that a lot of our clients like to use, like the eye tracking from Smartai Pro to find things like time to find. So how quickly from when they initiate the task can they find exactly where on this large screen where things are to minimize distraction? Once they find it, how much time are they spending looking at that particular thing in order to understand what it does? And so things like time spent looking at it, maybe facial expressions to look whether or not they have a negative or a positive expression, different types of arousals or expectations. If they're frustrated, they might get more excited. And by looking at these types of things in different demographics, you can look at saying like, oh, okay, it works great for men in Europe, but men in China, maybe they don't understand it. Maybe they can't find it here. Maybe women who are shorter on average are having a tougher time with this head-mounted display because it's all the way up here and they have to sit way up high and they have to kind of look at that HMD, through that display, and they're just having a more difficult time to going that. And so by measuring, I think incorporating these types of tools in the future, we find that our clients are able to sort of accommodate and address a lot of those types of concerns across different demographic groups, cultural groups, as well as people with different experiences. You also have to take that into account. So how, if somebody needs a certain amount of training in order to even drive and operate that vehicle, where along that path are they?
Thank you very much, Nam. This leads to my mind a thing that some colleagues of Davide told me about the relationship between the height of the driver and Lamborghini car. Their example was if an NBA player were to buy my car, there would be an issue of managing this kind of thing. But what Ulf and what Nam put on the table is the fact that we have to be purposive in the design of HMI. And so this second and unfortunately due to time limitation last tour of questions will be about the role of simulators in improving HMI, trying to understand within the limits of confidentiality how, for instance, the OEM are using simulators in order to improve the HMI design.
Yes, I think that it's most important to have a properly simulator in order to make in advance what will be the feeling with the car of the customer. So this is an issue that we have at the moment because principally the only one thing that we can do is to replace some video on the targets like instrument cluster or central display or passenger display, but at the moment it's not still present an environment and mock-up that represent the ergonomics and all the display. And this is an issue on we are working. Because principally the problem also at our side is that all the vehicles, principally 3 different line of vehicles, have a different target. So each car have a different instrument cluster, different central display, and a different ergonomic. So our challenge is to create a sort of a simulator that allow the possibility to switch from a project to another with the same structure in order to make all, for example, the presentation to the some people, in order to make more statistic the possibility to evaluate the HMI, to the board with the one simulator, the possibility to replace all the cabin, all the vehicle that we have. So this is at the moment the problem, because it's also so difficult. So I would like also the opinion about this kind of topic, because principally it's so difficult to represent the same resolution of different display present inside the car with, for example, a generic cluster, a generic display, in order to reproduce the design on top. For example, we have our design department that realize all the graphics, all the PSD and all the stuff in order to visualize on the target. But at the moment we need something that make animated all of this stuff on different target.
That's a very good point, Davide, and somehow it is also something that raises a challenge for OEM, considering, for instance, how much players from IT are entering the mobility industry. We fantasize of Apple Car since 10 years, and all the main players are moving in this direction. Fabrizio, what about Maserati's approach to simulation and to testing applied to HMI?
Basically, our approach is to use different instruments to provide different evaluation. So, generally speaking, we have different moments into the product development. The first of all is standardized flow feature creation that is possible without specific coupling to the vehicle, and this process is possible to assess the HMI with, of course, a driving simulator, developing separately the features and using the driving simulator to measure with expert evaluation first and the user test then how the feature is going. So if it is usable or not, if it is well accepted or not, if it is well designed. So if the feature meets the heuristics and other subjective and objective evaluation that we are able to do in our driving simulators. Another instrument that we can use is specific driving simulator that mixes the driving aspects with the virtual reality. It is a pretty huge thing that allow us to bridging the gap between the standardized production of feature, let's say, to the vehicle production. So we can anticipate the feature coupling with the vehicles. The third aspect, the third instrument that we can use is instead a real driving static driving simulator that is very close to VI grade. So we are in this meeting, and this is of course why we cooperate with VI grade too. And in this third instrument we can match what Panos said. So something that is very close to the vehicle development. So we are able to reproduce the ergonomics, and meaning the driving posture, meaning the distances between the eye point to the displays, meaning the reach of instruments on the dashboard, and we couple these aspects related to the physical ergonomics to HMI and user experience into the driving simulator. So we are able to collect, even in this case, the expert evaluation. Not only we can manage to collect also product sensitiveness or top manager position that is always very useful to to address the product development. And this is a powerful instrument to disseminate inside our company how the project is going. So we are able to address changes as soon as we can, and of course save money, reducing to zero the prototypes, and be very coupled with the shorten of productive timeline.
That's a very good point, working on simulation in order to decrease the time to market. So
yeah,
that's an important issue. I would like to pass from the perspective of OEM to the perspective of those who work on innovation solutions like Panos and Paolo. In particular, Panos, Fabrizio somehow scored an assist towards you, because he was talking about methodological aspects like working in silos or working all together in the experience and so on. What's your viewpoint on this regard? Which is the best way, according to you, to test HMI?
So, mindful of the time, I will try to summarize in 1 minute. So, in general, I try to do 80–85% of my tests on the simulator. What Davide and Fabrizio mentioned, it is exactly the challenges and the opportunities we have within simulation. Stakeholders, they can come and see it, they can realize the test, we can buy in from the stakeholders. So the majority of the tests we do, it is within simulation environment. Obviously, we do the final validation on the ground truth is with a real prototype, but it is very expensive, and simulation is a great tool. I'm using it for more than 10 years. Also, we can fuse data from, let's say, for example, from Smartai, and with iMotions, we can synchronize different measurements, objective and subjective. So we use advanced simulator, and we have worked in the past with VA grade for 80%. The challenges and the opportunities within the simulation environment, it is the adaptability. Davide mentioned about different architectures of HMI. So the system needs to be adaptable to accept different prototypes, whether it is display or different steering wheels, and of course, driving positions. In our case, we have from a car to a bus. So there is a huge delta between the occupant packaging. So back closing with Paolo's fluidity, we need a system that it is very flexible in terms of architecture for human-machine interface and for driving position. But definitely 80% of my testing, it is maybe a little bit more, it is within driving simulation.
Thank you very much, Panos. Somebody once said that the difference between theory and practice is bigger in practice than in theory. And let's say that this deals with an issue that is very consistent to what Paolo called fluid HMI. In fact, my next question to Paolo is this one. One of the issues is that the real impact of HMI can be seen in a specific case of use of driving. So working on simulation, how is it possible to recreate the real situations and conditions, for instance, the environmental conditions, making HMI essential in that very moment in order to get a test that is more reliable?
Yeah, I would say I will turn your question the other way around. How would it be possible without simulation? Right? So, I mean, if Panos uses that for 80–85%, I can quite relaxed say that we use it for 95–99%, where the remaining 1–5% is done immediately before or after the simulator session. So, and around the simulator. So, driving simulation is for us an absolutely essential, the most important tool for our research, right? That the flexibility that allows, and the flexibility that I agree with Panos, it is not yet sufficient. I mean, we will need even more flexibility than that. Indeed, we have taken a VA grade, pretty standard driving simulator, and we have completely changed it, and we have transformed that into a climatic chamber to study thermal and acoustic comfort and the interactions of them in electric vehicles. So it's a completely revolutionized system. It's a system that continuously evolves to adapt really to each new research question, right? And when it comes to HMI, it's not only about having as many flexible screens as possible, but it's also about how can we integrate different sensory modalities. So how can we use sound? How can we use visuals? How can we use tactile information to communicate with the driver? And that's also one of the reasons why we absolutely need a driving simulator. It will be physically extremely challenging, let's say, to stay optimistic, to do that in a physical prototype, or in a pretty much infinite series of physical prototypes. So the driving simulation is really the master tool for the front end research when it comes to HMI. And frankly speaking, there is no other way around it, other than possibly one is, let's say, a wish for a near future development in the field, the integration of virtual reality and virtual reality devices into driving simulation and driving simulator tools, right? So my dream is to have a driving simulator where 4 participants can sit and all 4 of them can have their realistic experience that is not just a driving experience, but it is the experience of being in a vehicle on a road. And so that's still something not right there. So it's let's say the next frontier, I would say.
Thank you very much, Paolo. And this raises an issue that is, of course, the more we want to be realistic, the less we have to be extensive in our testing. So we have to work on small sample testing, and this forces us to move from merely qualitative evaluation to more objective evaluation. Here is where biometrics enters. So I would like to ask Ulf and Nam, in order to conclude this roundtable, 2 bits of information. The first one, what is the current role of biometrics in HMI testing? Second of all, like a game, what is your big bet for the future? That is the future development of applied biometrics for HMI testing. Ulf.
So first question, what is the current role? Simply speaking, you would use an eye tracker, for example, in the simulator, also in the car on the road for testing, of course, to get evidence, saved evidence on what the driver actually is looking at. Where is he looking? When is he looking there? Is he missing something? Does the HMI enable the driver to operate the vehicle in an optimum way and in a safe way? And I'd say that's the main usage for HMI R&D or HMI design today of the eye tracker. Now, you add to that other biometric sensors, a range of them, EEG, EKG, GSR, etc. And Nam is more the expert there, so I leave him to that. But when it comes to the future, what we see in terms of automotive is a switch or an evolution of the DMS systems. And I would think that also the HMI will be affected by this going forward. But today we spoke about DMS, so driver monitoring systems. There is a movement now towards what is called today interior sensing, where you not only monitor the driver, you also monitor all the occupancies and objects and children or infants and pets even. So I see that this will be relevant for the HMI in the future as well. What can be detected in the car to even further increase safety? How many occupants do I have? How are they positioned, or how are they sitting? What are they doing? Are they sleeping or reading or eating, for example? These kinds of activities. If there is a child seat in the car and the car is stationary and there is an infant in the seat, that could be detected, and you can warn the driver who might not even be in the vehicle, for example, and the same thing with the pet, etc. So I would think that the HMI needs to see this in the future, and this, of course, also has to be tested and developed. And again, this is going into simulation and that kind of activities.
Thank you very much, Ulf. Nam, your company works on multimodal signals. And you talked in your introduction about such issues as the face reader, the integration of eye tracking with ECG or EEG, and so on. Can you give us some quick examples of KPIs that, according to you, are particularly relevant in HMI simulation? And instead, my question on the future for you is particularly focused on virtual reality. That is the possibility of working on biometrics to virtual reality, if you believe in this, and what do you see for this kind of future?
Yes, I'm going to answer the second question first. Is that absolutely, I believe that virtual reality is going to play a huge role going forward. That's why we've partnered with VR companies such as Vario in order to help bring that eye tracking data alongside all the other things into the research software. And we currently do that today. And using that insight into being able to flexibly change your environment, flexibly change all the things that you can interact with on the road as cars become more complicated, as more systems are in between the driver or the passengers and that road surface, how to go about configuring all the different systems so that they respond correctly and they respond in the best way to improve safety, workload, and such. Biometrics all along the way, it really depends on which question, whether you're reducing workload with say EEG brain metrics, galvanic skin response, heart rate changes and such, whether you're increasing the sort of familiarity and enjoyment of a situation, so making them more excited, more awake, more alert, whether you're looking to reduce workload when interacting with different types of tools and simulations. These are all different KPIs that can be assessed with the current tools and technologies, and that's what our clients are doing right now. And so I think in the future, we're most excited about very similar ones with Paolo's sort of fluid things, where you're increasing not just the state of one individual and how they're interacting with the car, but the states of multiple individuals in a network. And so now you're looking at group safety and group expendability as there as well. So everything from a fleet management system to a city network. I think we'll be very excited to see in the future.
Thank you very much, Nam. I personally agree with this multimodal issue, and it's also because it's where I do research. So it would be weird if I didn't trust in this kind of future. I see that Fabrizio has a question for you, probably.
Yes, Nam, I would like to ask you specifically for monitoring the driving distraction. What do you suggest to use about psychophysiological data, if you have any experience in that?
So distraction can be defined as a number of different ways. So it depends on the task. So there's distraction away from the road. There's distraction if you have a driver assist system. Now all of a sudden distraction isn't the same thing, because now you have a self-driving system that is now driving the car. And so what you're specifically paying attention to at that moment in time. Distraction so that you can accomplish a task like changing the radio as quickly as possible. And so maybe like if you're distracted while you're accomplishing a task, your eyes may not be on the road, but you're looking to try to accomplish that task as quickly as possible. So you have to define where you're supposed to be paying attention to, and eye tracking is a fantastic way of doing that. And blinks and things like that can measure immersion in the middle of that type of thing. So if you're blinking a lot while you're trying to accomplish a task, maybe you're not in that flow state in order to try to do it. GSR and other types of things can measure whether or not you've become emotional during that task. And so if you're frowning in the task, like, oh, how do I change this dial? Those types of things can be coded in the moment. And so and if you're doing it the old way, where you're just sort of asking them, is that a good place to put that? That's kind of like asking someone that wants to write a good book, can you tell me every page that something interesting happened in the last good book that you read? And you can't do that. But having a recording of that data as along the way, you can now know which page, which sentence, which word is driving that reaction. That's the same for car UI. So.
Yes, and this in conclusion is a very important issue that we have to take into account because it is probably the sweet spot of biometrics, as Ulf and Nam can probably confirm. That is, in general, we tend to ask things such as, was it difficult or not to do a certain kind of thing? But when we ask a thing like this, we are asking what kind of effort is perceived when we do it. There are not things that are difficult or easy subjectively. There is a mental workload that we have to work on. And that's why objective measures should match this kind of testing. Guys, we went a little bit longer, so I am sorry, first of all, with the panelists, because we went a little bit long, and with the participants, and I would like to thank them for their patience. I guess that if we wanted, we could go on for the next 8 hours, probably. And probably it would not be enough to conclude the topic, but the schedule is a little bit tough. It's always Friday night in Europe, and so it's 6 p.m. In Central Europe. So I would like to thank all our panelists, Panos, Paolo, Fabrizio, Nam, Ulf, and Davide. And I would like to thank you all for participating, and wish you all the best for the remainder of this event. Thank you very much.
Thank you too.
Thank you.
Have a nice
weekend.
weekend.
Leonida. Thank you, Leonida.
Bye-bye.
Thank you, Lucio.